Okay, sorry about that. I accidentally hit stop instead of finishing the problem. So anyways, what I was going to say is if you, on your calculator, type in tan of 17.4, some of you have to type in 17.4, then hit the tan button. Some of you hit tan 17.4 and hit equals. Big surprise, you get 0.313. And so I've basically shown you here is something called the tangent ratio, which basically says that for any right-angled triangle, if you know the angle and you know the opposite side and the adjacent side, or you know at least two of those pieces of information, it's always a consistent ratio. So for 17.4, the ratio of the opposite side over the adjacent side is always equal to 0.313. It doesn't matter um, how big or small the sides are. Let's just go back to GeoGebra and prove that. Okay, so here's our triangle. I'm going to keep the angle the same, but change the size of the triangle. Okay, so it's still 17.4. Okay, now I have two new sides. I have an opposite side of 1 and an adjacent side of 3.2. And if you do the math on your calculator, tan of 17.4 is equal to 0.313. Did that already. And 1 divided by 3.2 is also equal to 0.313. It's the same. Okay, I mean, there's some rounding errors going on if you're doing a calculator, but it's the same. Okay, so that works for every triangle, no matter what the angle is. So I can change the angle and the ratio will be the same, opposite over adjacent, no matter what I do. Okay, so for a 30-degree angle, the tangent, how rude. Okay, sorry. So for a 30-degree angle, the tangent ratio, oh, I can figure it out on my calculator. Okay, and on my calculator here, I have to do 30 and then go tan. It's equal to 0.577. Okay, that means if I take my opposite side here, 6.1, and divide it by 10.5, I should also get 0.577. So I go 6.1 divided by 10.5. Okay, and I get 0.5. Well, okay, so there I'm a little bit off, but again, it's because of a rounding error. Don't get all freaked out. Yeah, BB's wrong. It's not. I'm not wrong. I'm right. Okay, so there you go. It works. Okay, trust me. Um, so that tangent ratio is always the same, ignoring rounding errors. So that actually allows us to solve for unknown pieces of information. So for example, since I know that tan 30 is always equal to 0.577, if I don't know the opposite or the adjacent side, I can figure it out. Watch how we do that. Okay, consider this triangle here. I'm using 3 root 2 as my adjacent side, and I'm doing that to avoid any rounding errors, just to prove to you that I'm right, because I am supreme. And so looking at this triangle here, the tangent ratio for 30 degrees, if I'm trying to find this value here, the tangent rate for 30 degrees I know is 0.577. And that tangent ratio is equal to the opposite side, x, divided by the adjacent side, 3 root 2. Okay? Tan 30 I can do on my calculator, and I get that, 0.577 rounded equals x divided by 3 root 2. Okay, so if I wanted to figure what x is, I just need to solve for x. This becomes an algebra problem you did back in grade 9. Multiply both sides by your denominator. In other words, multiply by 3 root 2. Multiply this by 3 root 2. Okay, and this is all just doing some math here. You work that out. And on the right side here, the 3 root 2's cancel out, so I'm left with x. 3 root 2 times 0.577. X is equal to 2.4. I meant to label this as 3 root 3 instead of, but what doesn't matter. Anyways, I was going to show you how perfect I was, and I totally screwed up. And now it's on video. Excellent. Okay, so let me set up another one here for you to try, see if you can work it out. Okay, so here's a problem here. You have the angle 25 degrees. The opposite side is x. The adjacent side is 6 root 3. So I'm going to stop the video and we're going to move to the next video here. But in between then, I'd like you to try to solve for x using the same method that I did before. Okay, so tangent of 25 is equal to x over 6 root 3. Make sure you can find what x is, and we'll compare answers in the next video.